Hello all, welcome to another session with me, Varun on Tech Tablet. In this video, we would be starting on an entirely new series. We would be looking at each and every unit of the AKNU syllabus, that is Adikavi Nannaya University. And with respect to this, we would be beginning with the first unit of the subject, that is data science with R. Okay, now this would be split into two parts wherein we would be having the theoretical and the practical both separately. And I think this is completely exam ready. You can just take a look at these videos, have a basic understanding of the subject, go write your exams, and I think that should do a really good job. So in this video, this is a completely free video sponsored from Tech Tablet. In this video, we would be looking at introduction to the data science process, which happens to be the first unit of our language. Now, before we go further, let us have a basic understanding of what is the agenda. So while we are looking at the unit, we would be looking at two parts, wherein the first part would be theory, which is what we're looking at right now, and the second part would be practical, right? Now, both theory and practical would be separate videos, and in theory every unit would be split into two parts except the first unit. Okay, so in total we have 5 units, so that makes around 10 videos of theory. And coming to practical, we would be uploading 3 to 4 videos of practical that would be following completely as per the syllabus. All right, now what is it that we would be covering today in this specific video? We would be understanding with an introduction of what is data science, followed by the definition. Even now, we see that with this kind of an exposure to data science, when someone asks what is data science, we give very weird definitions that might not always suit to the market industry. So we would be looking at the definition of data science. We would be looking at what are the various fields in which it is being used, and obviously some examples related to it, followed by the impact and understanding the data analytics lifecycle, the data science toolkit, what is a data scientist and what does he do? I think this is a question that a lot of us have. Like, what is the primary role of a data scientist and what is it that he's expected to do when he gets a job? What is a data science team? What is EDA, that is exploratory data analysis, the most important part of any data science journey? I think I would give this 5 stars. And what is feature engineering, followed by data transformation, right? Now EDA is very commonly also referred to as data cleaning, right, in which we have different steps involved like data manipulation, data transformation, etc. But yeah, it is basically referred to as data cleaning. Now, all these topics that you see, these are directly your part of the syllabus of AKNU, as per provided by the AKNU. So you can just look at these videos and probably go give your exams and come back. Now, the first topic that we have is what exactly is data science and where do we need it? What does it do? Why? And all. We'll be looking at the what, where, why, how, etc. of the data science now. So firstly, when we talk of data science, it basically means we are trying to extract meaningful information or insights from its raw power, right? Now, when we are extracting meaningful insights, what do we mean by meaningful insights? Again, now let us say you're working for an organization, probably you're working for the traffic police department. Now, you don't need insights like insights about the crime rate, or insights about the inflation, or insights about what is the stock market performance, because all these are not meaningful to your current project or your current requirement. So data science is basically to be able to remove or to be able to work on the meaningful information, which is the raw data, and you would be able to extract insights from this kind of a raw data. Now, in this generation, there is, no other gold. I think data is the new gold, right? Whoever has data, I think that person is the richest person in this generation. Now, where do we not see data? I think we see data everywhere. It could be health, it could be, finance, it could be, industry, mechanics. I mean, you just talk about it. We do not go ahead without the data. Now, what is the most important thing that you need to do? That is, you need to ask the right questions, because without the right questions, you would not be having right answers. And this is where a data scientist comes into play. Now, what is a scientist? What does a scientist do? The job of a scientist is to basically ask as many questions as possible. Yeah. So they basically live on Q&A mode. I think this is where their living comes from, right? And whatever questions they have, they try to generate these questions into meaningful insights, which give them the capacity to move on to the next part, right? Now, to this, what exactly is data science? Let us understand step by step. Let us take this slow and steady. And every time you watch the video, I would recommend that you please maintain your running notes, or probably you could write these down, so they help you when you go to your exams. Now, what is data science? It is an interdisciplinary field. Please pay attention to the keywords here. And it uses scientific methods. So it would not be wrong to say that this is complex or high level statistical computing, right? Because what we are doing here is we are unleashing the capacity of different methods, different scientific methods, to be able to come up with different processes, algorithms, and systems to extract knowledge from structured and unstructured data. Now, if anyone tells you that they work only on structure, I think that is the biggest mistake that they would be doing. Because when it comes to data science, we work on structured as well as unstructured data. This is the first one, and this is the second one. Though we all do not work on unstructured right on day one, I think it takes some experience, some knowledge, some process knowledge, some coding knowledge to be able to go, or to be able to promote yourself from structured to unstructured, extraction. Now, what are the key components that get involved when you're working on data science? The first one, obviously, is statistics and mathematics. You have programming. In this specific programming, we are learning R, but otherwise you have Python also, which is a very important programming language. Then domain knowledge, I think this is very important. And domain knowledge completely depends on which industry you're going into. Right now, if you are in the medical field, then you're expected to have at least basic domain knowledge on, basic medicine, right? And if it is finance, you're expected to know some basic financial terms, because no one would be, coming to you every now and then to explain what it is. And finally, you have data visualization. Data visualization is to be able to project your insights, so it is easily understood by the end user, or by the viewer, or by the client, right? Now, finally, just to sum it up, data science, it's not about just coding, it's not just statistics, nor is it just stats. It is basically a combination, a very powerful combination of all of these together. I would say it is coding plus statistics plus making charts. Now, this is the most important takeaway from here. Now, just as I was talking, we see how coding or data science is rather involved in every field, at least in this generation. Let's talk about healthcare. You have disease prediction and drug discovery. In finance, it uses for fraud detection and credit scoring. Now, let us say you want to apply a loan, okay, probably a loan of X rupees, right? Now, when you want to apply a loan, what is it that we do? We approach a bank, the bank checks our status, the bank checks if you are eligible to get a loan in the first place. Now, while these checks are happening, I think the days of manual checking are long gone. We have algorithms that now take over the process. They go through your entire profile, they see if the credit score is matching, and then they go on to the next step. And last, you have retail sector, wherein you can see it is used heavily in recommendation engine. Recommendation engine is not just used in retail sector, it is also used in e-commerce very heavily. For example, Amazon, where you see how products are recommended to you. You have Netflix, where movies are recommended to you. So all these, fall into, the recommendation engine, purview. Then you have education, where you have personalized learning. You have, really good tools, or learning platforms like Byju's, etc. What these do is they understand you, they understand how fast you're able to grasp the syllabus, and based on your performance they generate questions for you, which is not easy, right? Then you have, it is also used in transport, like when you're using Google Maps, like Google Maps, or probably Apple Maps, when they give you a direction and they suggest to you which is the shorter route. I think there's a lot of optimization and driving knowledge that's happening. And agriculture, all modern agricultural practices use machine learning just to see how the crop would predict and what would be the outcome, assuming we go with XYZ variant of crops. So data science is really taking over in a lot of worlds. Just as discussed, you have Netflix, which is showing you the recommendations. You have Google Maps, which predicts things for you. Then you have Amazon. Amazon, is also using collaborative filtering to be able to recommend a set of products to you, or to be able to give you items of your choice. And even when there was COVID tracking, government, tracked and predicted the spread using ML algorithms. So if that is the kind of impact we have using data science, then I think you understand the demand that data science would be generating in the market in a few years. Now, the great thing here is all of these can be built using R as well. Now, there is a very, very big hype, I would rather call it, in the market, saying that Python is the dominant tool, which is 100% true. However, it would be false to say that R cannot work on almost anything that Python does, because R is as capable as Python. However, there are certain areas in which Python probably dominates a lot of other tools. Except this, we see that both the tools can be used to your capacity, assuming you work on them well. Now, what is the impact of data science? We all know how data science is changing the world. Just less than 15 years back, less than 15 years back, the data that is generated is, almost, 10 times less. And now we see how the data has increased 10 times, which is probably still lesser, because when we talk about the period which is 15 years back, we see how digital innovation, or how digital dominance has not yet spread to all parts of all the countries. But now we see that even in a very small village or a town or a metro or a rural or urban, we see how technology has very strongly, dominated in all these areas. So with the rise of technology, we need better algorithms. We need sharper algorithms that would be able to, create an impact. So here is the impact of data science. We see how 2.5 quintillions of data is created every day. This is not a small amount. We are not talking of GB or TBs. We are talking of QBs. Okay. Now, because of this kind of data, it becomes imperative for any organization to stick to older technologies. So you have almost 11.5 million new jobs that have been created by data science, which is called as the demand of the market. So this is the demand in the market. And with this kind of a demand, LinkedIn has rated data science jobs as the number one in demand jobs in the market globally. And because of data science, we see how businesses have boosted their business efficiency by 40%. So is the impact small? No, the impact is definitely very huge. Probably it has not yet reached every doorstep, but yes, the impact is pretty huge. As you can see here, it would not be wrong to say that from saving lives in healthcare to personalizing your playlist, for example, Spotify. Okay, now if in case you think what playlist are we talking about, then probably Spotify playlist or YouTube playlist. We see how these are, personalized, and thus it would not be wrong to say that data science is indeed a revolution, right? Now, what is the data analytics life cycle? So, firstly, you need to understand your problem statement, like what exactly is the problem you're trying to solve. Now, once you have understood this, you would collect the data. Now, for data collection, you depend on multiple sources of information. Okay, the sources could be websites, or it could be CSV files, or it could be Excel sheets that you might receive from multiple places, or it could be backed in any server. So yeah, we don't know the source of information, but there would be a lot of information that you would have to collect, probably from multiple sources as well. Now, once this is done, you would be choosing what is the method and what is the approach that you would be taking to build the final output. And once you have the methodology, you would be building a model. Here, mostly you would be having the introduction of machine learning, wherein you would be building a machine learning model and you would be taking a test case and a train case, right? Now you would be training your model on the trained data set, and you would be testing it to see how it is performing on the test data set. Finally, you would be using visualization. That is, you would be using, you would be unleashing the capacity of different graphs or charts. To be more specific, you would be using different graphs or charts to generate the inference. Basically, now why do we need all these? This is to generate an inference of what exactly you're trying to showcase. And finally, you would deploy it. Now, before deploy, again, there are a lot of things that happen, like test case, and then you have an MPV that goes into the market, which gets tested. Now, then again, you would be having the testing results that come in. Now, once the testing happens, again, there are many approaches, like you have A/B testing, you have feedback testing, you have response testing. Now, after all these testing is done, you would again get it back, and if there are any changes to be made, we make the changes and then we redeploy it with the requested changes. So every phase that you see is iterative. It is not necessary that one phase moves on to the next and never returns back. Okay, because now let us say you chose the model, like in step 3, you chose the model, and you might have your client who might tell you that, what, I forgot a piece of information, you need to add this as well. So it is very true that every phase is iterative, and you may revisit each step as per the need. All right, there's no hard and fast rule that this is only a unidirectional process, right? Now, what does a data science toolkit have? You have multiple languages. Let us currently focus on R and basic, So the R language is the first. This is actually called as, a statistician's tool. Okay. Why? Because R was built for statisticians, right? And to use R language, we have a tool which is called R Studio. Okay. R Studio is like an IDE, an interactive development environment, or an integrated development environment where you would be able to, code multiple things, and you would be able to, run your R code. And to be able to unleash this capacity, we have multiple libraries like ggplot2, which is for graphs. Okay, GG stands for Grammar of Graphics. Okay, let me just write it here for your reference. Grammar of Graphics. Right here, we are basically trying to understand how graphs work, right? Then you have dplyr, which is for data manipulation as written here, and tidyr, which is, for data tidying and reshaping. All right. So what is the general routine of a data scientist? Like, what is a data scientist? What does he do? So he goes in the morning to the office, he explores and cleans the data. In the afternoon, he builds test cases, and finally he presents the findings. This might not be as simple as morning, afternoon, and evening, but yes, one day he might work on this, the second day he would be building models, and the third day he would be presenting the findings. And again, the approach goes on and on and on. So all of this starts with critical thinking or statistical thinking in the first place, then understanding the tool and understanding the language in the second place. When you get the data, you need to know what is, data wrangling. Also could be very easily understood as data cleaning, or probably EDA. Then you have your machine learning, which would be applied. All right, again, it's written as basics, but it could be even the high level or basic level. After this, you would be visualizing your data, and finally, you would be having storytelling. Storytelling can also be, called as inference or interpretation of your information. So you have these parts that every data scientist follows on a day-to-day cycle. Now, what is a team? Again, it is not a one-man show. Please understand. I think it's very rightly written here. It takes a village to build a data product. Why? Because one person would be working on the front end, you would be one who's working on the back end, you would be having one who's working on data pre-processing, one who would be working on collection of data. So when we are talking of a business analyst, his major job is to define the problem, understand the goals, and work on data cleaning or data manipulation. Then you have a data engineer who works on building pipelines. That is what comes first, what goes next, how would A, B get affected by C, things like these. Then you have a data scientist, I think one of the most crucial roles, who would be working on building the model and extracting the final insight from the information. Then you have a data analyst. Please understand, business analyst and data analyst are two different people. Where a business analyst works on defining the problem and goals, a data analyst works on achieving the problems and the goals as discussed by the business analyst. So it would not be wrong to say that these two people work hand in hand. Finally, you have a data visualization team. Again, this is not necessarily available in every organization. However, based on the size of organization, you might have a data visualization team which communicates insights visually. And finally, you have an ML engineer. This is the person who takes your product to production, to the launch phase, or to launch the product. This is the guy who needs to give you a go ahead. So this is usually how the team. Now, if you are a fresher into the market, then mostly you would be either a business analyst or a data analyst. Now, this is where your role would stop by. Now, let us finally go into the actual parts of understanding the data. So, after you have understood the data and you have explored the data, the first part that we need to do as a mandate is exploratory data analysis. Now, what happens here? Here, you would be checking the information, wherein you would be checking the shape and the size. You would be identifying missing values. You would be understanding the distributions of different columns. You would find correlations, spot outliers. Again, I think this is not even 10 to 20% of what an actual data scientist does, because there's a lot of drama that happens. Notwithstanding this, you might have to normalize the data, standardize the data. You might have to work on binary values. So what is written here is very minimal, right? So like I said, you have different things that go into picture, like standardization, normalization, right? You have Boolean values that we work on, right? And you might have to add new columns, that is impute information based on the problem statement. So there's a lot that goes, right? And to do this, this is what we call as EDA, which is exploratory data analysis. Now, after this, you have feature engineering, wherein you're trying to present your raw data into the meaningful input for the model, right? So here, when you're talking of feature engineering, you would be also you taking your domain knowledge into consideration, where you create, transform, or select variables to improve the performance. Now, within feature engineering, you have feature creation. Like, you have a data given to you, and within the data, you are extracting a certain piece of very useful information. For example, you are extracting the day of a week from a date to create new meaningful insights. or you would be using feature selection to keep the most relevant features, okay? Or you would be working on feature transformation. That is, you have scaling, you have normalizing, or you convert the categorical values into numerical values. So all these are a part of your feature engineering. The next thing is your data transformation, wherein you would be preparing your data into models that can be actually understood. Okay. Now, again, in data transformation, you have the same steps that were discussed just in the previous slide, like normalization, wherein you would be arranging your data between 0 to 1. You have binning, wherein you are trying to group your values into categories. Again, not each and every step would be applied to every data set. It depends on the problem statement. So what is the most important thing that you need to understand before you go or before you choose? I think that is the problem statement. And based on the problem statement, you would derive the flow logic, right? So by the end of this unit, I am pretty sure you have understood the first one, that is what data science is. You have understood the data science life cycle. You have understood what are the basic steps that we perform in EDA. Again, we will have a deeper look at what is EDA in the next unit, but we have known what EDA basically does. Then you have feature engineering techniques, which is 4. We've understood what is data transformation, which is 5, right? Notwithstanding this, we spoke about a few tools. Again, not few in, to be sure, but we only spoke about R because this unit deals with R, but there are a lot of other tools, a lot of other languages that go into the actual picture. Then finally, we also saw what does a data science team do. And just for you, to know, the goal is not to be perfect. The goal is to understand, explore, and keep learning. Now, if in case you're looking forward to be a data scientist, then please remember there is nothing called as failure or wrong. You have just explored another way of how not to do it. That's as simple as that. Going forward, in the next video, we would be looking at the unit 2 of your R language as per the AKNU syllabus. Okay. And in unit 2, as I said, we would be splitting it into 2 parts, right? The first part would be covering 50% of your syllabus. The second part would be covering another 50% of your syllabus in unit 2. And from unit 2, you have a lot of practical as well that slowly comes into picture. So we would be focusing on those. If in case you have any queries or any suggestions or anything that you want to ask or that you would like to know further about, please feel free to drop it in the comment section below and I would revert back to you at the earliest. Thank you very much. And if in case you like the video, do not forget to hit the subscribe button and the bell icon for regular notifications. I'm hoping you all have a great day. See you very, very soon.